Hello everyone, welcome back to Lead Coding. In today's episode, we will be talking about recursion and backtracking. So the motive of this video is to make you understand what recursion is. There's a large class of brute force problems that could be solved using backtracking. Then there are lots of questions from the topic trees and binary trees that could be solved using recursion. They are mostly asked in your interviews. Then there is a very important class of problem called dynamic programming problem, for which if you are able to write a recursive code, you will be able to change it into memoization by changing just a few lines of code. So recursion and backtracking are very versatile in nature. They are very frequently used in comparative programming questions and your interview questions. So the flow of the video is going to be like this. We will be learning the theory of recursion. Then we will see a few questions on recursion. We will be moving to the backtracking. Then we will solve questions using backtracking. So these are the questions that we are going to solve today. First of all, we will be solving the factorial problem. Then we will be solving permutations. Then n-queen problem. Then we have the kth lexicographical string of all happy strings of length n. So these are the problems which we will be solving in this video. But the best way to learn recursion is by practicing. So there's a complete playlist on the topic recursion on this channel. You can go there, try out problems, and one of the most important thing is to check the description box and the comment section when you are watching this video. Because in future, whenever we are making a bit advanced video on the same topic, or maybe if we want to provide some extra questions to solve, we will provide it in the description and in the comment section. So always do check it while you're watching the video. Alright, now let's start with the recursion. So what is recursion? Recursion is basically a function calling to itself. So for example, we already know in C++ we create functions. So here's a basic C++ program in which I'm creating a function. So I'm calling it REC. I'm not passing any argument. And the only statement that I'm going to write in this is hello with a space. Now the very next statement is REC. So REC is a function which is calling to itself after printing a statement. So now let us call this function from our main function. And now let us try to run this code. So here's the output. So we can see hello printing infinite times. So I'm just going to stop this now. So we saw that the function REC is printing hello, and then it is calling the same function again, and the same function will print hello, and it will call REC again. So let us say we have this function main. Now from this function we are calling the function REC. So this is the function REC. It is printing hello, and it is calling another function which is REC. So it is calling to itself. Then REC is printing hello, and again it is calling to REC. So it is printing it again. And again and again. So REC is being called infinite times. So this is called a recursion. Recursion is a function calling to itself. Now why do we need recursion? We need recursion because sometimes there are problems which are repetitive in nature. So for example, there's a problem of size n, and inside a function we can solve a problem for size 1, and the rest of n-1 size problem could be solved using the same logic. So we will be solving the problem of size 1, and we will send the n-1 back to the same function using recursion. So this is where recursion comes in handy. So let us see one such problem. So you must have heard of something called a factorial. So what is a factorial? Let us say if we want to find the factorial of a number 3. So 3 factorial is nothing but 3 into 2 into 1. 4 factorial is equal to 4 into 3 into 2 into 1. 2 factorial is equal to 2 into 1. So can we write that 3 factorial is equal to 3 multiplied by 2 factorial? Because this is in fact 2 factorial. And can we write 4 factorial is equal to 4 multiplied by 3 factorial? Because this is 3 factorial. So here we saw that if a problem is of size n and we want to find n factorial, this we can write it as n into n minus 1 factorial. So if we have a function which is returning us the factorial of a number n, we are going to do one operation in that, which is multiplying n and then calling the same function factorial with the value n minus 1 and multiply both these values. So let us see the code for the same. So we are going to calculate factorial for a number n. Now as we saw last time, that when we were doing a recursive call, it was an infinite loop. The function was calling itself infinite times. So there must be a point at which this recursive call should end. This is called the breaking condition of recursion. So in this case, when we want to find the factorial of a number, so we already know that factorial of 0 is 1 or factorial of 1 is 1. So we can set any of these as the base condition. So if n is equal to 0, we are going to return 1. So this is the base condition. So now the answer is equal to n multiplied by the factorial of n minus 1. So calling the same function factorial n minus 1. Now let us try to print the factorial of the number 4. It is giving us correct answer, which is 24. Let us try to print the factorial of 5. 120. Factorial of 6. So it is giving us correct answer. Now let us try to see how these recursive calls are being made. So this is our main function. Inside the main function we are calling the function FACT with the value n is equal to 4. Now inside the function FACT we are multiplying 4 with FACT of 3. Now FACT of 3 is doing the same, multiplying this with FACT of 2. So it's calling to this function, it is calling to this function, and this is calling to 2 multiplied by FACT of 1. And this is calling the function FACT of 0. Now when the number becomes 0, it is going to pass 1, as we already saw here in the line number 7. So if n is equal to 0, it is going to return 1. So 1 will be returned to this function. Now 1 will be multiplied by 1 and it will be returned to this function. Now here 2 will be multiplied by the answer, which was 1, and 2 will be returned here. In this function 3 will be multiplied by 2, which is coming from the function call, and 6 will be returned to this function. Now 6 will be multiplied by 4, which is equals to 24, and 24 will be returned to the main function. So this is how the recursive call works, and this is how the recursion works. Now let us see a few problems using recursion. So the first problem is permutations. So we have to find the permutations of the number 1, 2, 3. We already know what a permutation is. So let us say we have the numbers as 1, 2 and 3. So let me fix 1 at the first position. So I'm fixing 1 here, and I will try to find the permutation of 2 and 3. So it will be 2, 3, or it can be 3, 2. Now next time I am fixing the number 2 here. Now I want to find the permutation of 1, 3, which is 1, 3 or 3, 1. Next time I want to fix 3 at the first position. and find the permutation of 1 and 2. So it could be 1 2 or 2 1. So these are the 6 permutations of the number 1 2 3. So how is it recursive in nature? So as we saw that we have to fix one number at a time at a particular position. So here let us say that we have 3 numbers 1 2 3. So we want to pick each one of them and fix at the first position. We had 1 2 3 in the collection and we wanted to fix one number at a particular spot. So like if we fixed 1, then I was left with numbers 2 and 3. If I fixed 2, then I was left with numbers 1 and 3. And if I fixed 3, then I was left with numbers 1 and 2. Now next time 1 is already fixed at the first position. Now let's say if I want to fix 2 at the second position. So 2 will come here and 3 will be left. And here I want to fix 3 at the second position. So 3 will be coming here and 2 will be left. In this case also 2 is already fixed at the first position, and at the second position if I want to fix 1, then 3 will be left. At the second position if I want to fix 3, then 1 will be left. Same with this. 3 is already fixed at the first position, and at the second position I want to fix 1, then 2 will be left. And here I want to fix 2 at the second position, so 3, 2 and 1 will be left. Now here we have only one choice for the third position to fix, which is 3. So 1 and 2 are already fixed, and at the third position I am fixing 3. Here 1 and 3 are already fixed, and at the third position I am fixing 2. Here 2 and 1 are already fixed, and at the third position I am fixing 3. So we have only one choice for the third position. Similarly in this case 2 3 1, in this case 3 1 2, and in this case 3 2 1. So these are the 6 possibilities. So this is recursive in nature because we are doing the same task of fixing a number from the numbers which are left at any particular index I. So let us see the code and it will make us more clear. So let us say if I want to store my answer in this, and here's my function. This will be my helper function, so I'm calling it help. In this function I will be passing the given array. I will be passing the index at which I want to fix particular number, and of course the answer I will pass it as a reference as well. Now if I is equal to nums.size, that means we reached the end. So we just have to insert the given configuration in our answer. So answer.pushback nums, and we have to return from here. So this is our base case or the breaking condition of recursion. Otherwise I have to fix a particular number at the ith position from the numbers which are left. So till the i-1th position we have already fixed numbers, and we won't be using those numbers again. We will be using the numbers which are left, and among the numbers which are left we will be fixing a particular number at this position I. So the numbers which are left will be the numbers I and beyond I. So I will be running a loop int j is equal to I. J is smaller than nums.size and j plus plus. So I will pick each one of them and bring this number at the ith position by a swap. So I'll perform a swap of nums of I comma nums of j. So anything which is present at j will be coming to the current index I, and then I will be calling the function help with nums I plus 1, because now we already fixed numbers till I and the answer. Now after the recursive call I am going to swap the numbers back again. In this step, we undo whatever changes we made in the line number 12, so that when we want to bring the next element at the ith position, it is the same configuration as it was initially. So this is called the backtracking. Now I will be calling this function from the main function, call help of nums 0 and answer, and finally I will return the answer. So now it is giving us correct answer. Let us move on to the next question. So the next problem is n queens. The problem statement is the n queens puzzle is a problem of placing n queens on an n cross n chessboard such that no two queens attack each other. So we are given n as a number and we have to place n number of queens on an n cross n chessboard, and we have to make sure that no two queens attack each other, and we have to return all such possible configurations. For example, when n was 4, there are two solutions available and we have to return both of these. So how can we do this? Let us see with the help of an example. So let us say we have the chessboard of size n cross n, and here we are taking n as 4. So this is the chessboard. Now the first condition is we can have only one queen in one row. So in each row we can have only one queen, otherwise they will be attacking each other. So this is our first condition. So let us start from here. Can we place a queen at this position? Yes, of course we can. So we will be placing the queen here. Now we will be coming to the next row, and in the next row we will see, can we place a queen at this position? No, because it is being attacked by this queen. Can we place queen here? No, because it is being attacked by this queen. Now can we place a queen at this position? Yes, we can. So we will be placing queen here. Then we will be moving to the next row. Now in the next row, can we place a queen at this position? We cannot. It is being attacked by this. Can we place it here? We cannot, because it is being attacked by this queen. We cannot place it over here, and we cannot place it over here. In the row number 3, we are not able to place any queen. And if we are going to ignore this, if we are not going to place any queen in the row number 3, so if we ignore this row and we didn't place any queen in this, so there's no way of placing the n queens in n-1 rows. We have to place one queen in each row. We got stuck here. We are not able to proceed. We know that we won't be getting the answer. We won't be able to place n queens. So we will be moving back. We will come to the row number 2 and we will see. We place the queen at the 3rd column, but we can also place the queen at the 4th column. So we will try to place it over that position. So the queen is at this position now. Now we will come again to the row number 3 and we will see, can we place a queen over here? We cannot. Can we place it here? Yes, we can. Now we will come to the 4th row and we will see, we cannot place the queen here, we cannot place the queen here, we cannot place the queen here because it is being attacked by this queen, and we cannot place the queen here as well because it is being attacked by this queen. So again we got stuck, and as we already discussed that we cannot leave the whole row empty. We have to consume that row and we have to place one queen in each row. So we are not able to proceed and we will go back. We will go back to the row number 3 and we will check that at what all position can we place the queen. So we were not able to place it here, so we place the queen here, and we will not be able to place the queen here, and we will not be able to place the queen here. Again we will go back to the row number 2. So we already placed the queen at the 4th column, but that's the wrong configuration, so we will not put the queen at the 4th column. So we are not able to place the queen at the row number 2 as well, so we will be going back to the row number 1. So in the row number 1, this queen was placed wrong, so now we will place the queen at the 2nd column. Now we will see. Now in the 2nd row, these cells are being attacked, so we can place the queen at this position. Now in the third row we can place the queen at this position, and then we can move to the fourth row and we can place the queen at this position. So this is one of the possible answer. So we achieved the answer. We placed one queen in one row, and by doing so we are able to place n queens in n rows. So this was one of the possibility, but we will not stop here because we are asked to find all the possible answers. So we will again go back and we will see the position of the queen in the row number 3. So can we place the queen here? No, we cannot place the queen here, we cannot place the queen here. So we will again go back to the row number 2. So in the row number 2 we cannot place the queen at the first 3 columns, and we have already looked by placing the queen at the 4th column. So we'll remove it from here and we will go back to the first row. In the first row we will try to place the queen at the 3rd column, and then in the second row we will be placing the queen here, and in the third row we will be placing the queen at this position, and in the fourth row we will be placing the queen at this position. So this is another possible configuration in which the queens are not attacking each other and we are able to place n queens. So these are the only 2 possibilities. So this is what exactly we have to do in our code. We will try placing the queen in each row and we will see for each column. So we will see at what all positions can we place the queen, and if we can place the queen at that particular position we will place it, and then we will move forward. When we move forward we will see can we reach till the last row, that can we place n queens by reaching the last row. If it is the case we are going to save that answer, otherwise we will backtrack. So let us try to see the code and it will make us more clear. So what I'm talking about is I will create a helper function. It is not going to return us anything, so it is void, and in this I will take I. I denotes the row on which I am currently working, and we have n rows in total, so I will take n as the argument, then a vector of string. This is to store the configuration, and then a vector of string answer. This is to store the configuration in which we can place the n queens. Now if I is equal to n, then we already reached till the end and we are going to save this configuration into our answer. So this is the answer, and we will do answer.pushback this configuration and we will return from here. Otherwise we will go from j is equal to 0, j is smaller than n. We are moving from the 0th column till the n minus 1th column, and we will see if this position is safe to place the queen or not. We will check if this position is being attacked by another queen or not. So how to check that? For example, if we want to place a queen in the row number 3, so let us say we are checking for this particular position, that if we can place a queen here or not. So we will have to see the column whether or not there's a queen. If there exists a queen, we will not be able to place it here, and we have to see diagonally that there exists a queen or not, and same with the right diagonal. So we have to move in this direction, we have to move in this direction, and we have to move in this direction. So if any of these direction, if we are able to find another queen, so that queen will be attacking this position, so we won't place the new queen here. So let us first create this checker function. We are creating this checker function which will be of return type bool, and it will take as an argument the positions I and j and the configuration of the board, which is vector of string temp. So this is the configuration, and as I told you, we will be moving in 3 directions. So I will be checking for, so x is equal to I, j is equal to y is equal to j, while x is greater than equal to 0 if temp of x comma y is equal to queen. In this we are checking in the up direction. So if temp of x comma y is equal to q, then simply return false from here. Otherwise move up, which is x minus minus. Again x is equal to I and y is equal to j, while x is greater than equal to 0 and y is greater than equal to 0 as well. So in this loop we are moving to the top right, to the top left. We are talking about this direction, so we have to do x minus minus and y minus minus. If temp of x comma y is equal to q, then return false. And x minus minus, y minus minus. Again x is equal to I, y is equal to j, while x is greater than equal to 0 and y is smaller than temp dot size. If temp of x comma y is equal to q, then return false, x minus minus, y plus plus. So in this case we are moving in this direction, so we have to do x minus minus and y plus plus. Finally, if we are not able to find any queen in these directions, we can return true. So we will check that if we can place the queen at this position using this function check, in which we will pass I, we will pass j, and we will pass temp. If we can place it, then we will be placing it here. So temp of I comma j is equal to q, and then we will call the function help with I plus 1, because we will be going to the next row to place the another queen, and n temp and answer. And after this we will undo whatever changes we made in the line number 40. So we will have to do temp of I comma j is equal to dot, because at all the empty spots we are placing dot. So I think this is enough. Now we will be creating this temp. So for that we will create a vector of type string temp, and I will create a temporary string s, initialize it with dots because the string is empty, and then I will put push back s into temp, then a vector of string answer, and then we will call this function help, in which we will pass 0 as the index, then n and temp and answer, and then we will return answer. Let us see if it works. CHECK, we should name this check. Plus equal to. So we are getting correct answer. Let us try to submit, and it got accepted. So this was the n queen problem. The next problem that we are going to solve is the kth lexicographical string of all happy strings of length n. So the question is, a happy string is a string that consists only of letters of the set a, b and c. S of I is not equal to S of I plus 1 for all the values of I from 1 to S dot length minus 1. So basically the s of I cannot be equal to s of I plus 1. And given two integers n and k, consider a list of all the happy strings of length n sorted in lexicographical order. Return the kth string of this list, or return an empty string if there are less than k happy strings of length n. So this is what we have to do. So I think this question is fairly simple. It is based on the same lines that we already discussed. What we can do, basically we can create a helper function of type void in which we can store the last character that we have used. So we can store this inside char c, that what we have used last time. Then we can store the position, because we have to create these strings of size integer n, length n. So we have to keep track at which position are we inserting the alphabet, and we will store n. Then so now what we can do is, if I is equal to n, then we can simply store. So we'll keep a temporary string, and we will keep a vector of string answer dot push back this temp, and then return. Otherwise we have to insert one alphabet at this position. So we have three options for that. We have A, B and C. So if C, the last character, is not equal to A, then what we can do is we can do temp plus equal to A, and then we can call the helper function with A as the last character, I plus 1, n, temp and answer. And yeah, we have to undo the changes. So we have to do temp dot pop back. If C is not equal to B, so A is a character here, then we have to perform the same thing. And if C is not equal to C, again we have to do the same thing. This time we are adding B, and here we are adding C. Here we are passing C, and here we are passing B. Okay, so now we will be creating a vector of string answer, a string temp, and then we will call the function with 0 with the last character as, we will pass anything except ABC, so we can pass it V. Then we will be passing 0 and n, temp and answer. After this we will have all the possible configurations in the answer in a sorted form, because first we are inserting A if we can, then if we can insert B, then we are inserting B, and if we can insert C, then we are inserting C. So we are inserting it in a sorted order. That's why we will have all the configuration in a sorted fashion. So finally, if answer.size is greater than equal to k, then we will return answer of k minus 1. Otherwise what we have to return? An empty string. Otherwise we will return this. Let us try to run this. So we are getting correct answer for the test case. Let us try to submit, and it got accepted. So we generated all the possibilities and we stored them in the answer, and finally we returned the answer. So this is how we have to do the backtracking. So the backtracking part is, first we are inserting something, then we are popping that back. So in this step we made some changes, and this step we backtracked. So this is it for the video. If you like the video, please subscribe to the channel. If you want more such videos in future, please comment down below the topic that you want to learn, and please don't forget to check the recursion playlist. Thank you.